Right, so we're going to start the second chapter of calculus. I was saying I wanted to get down to max and min problems just because it tends to get asked a lot. I actually don't even know if it's being asked on your mock. I've looked at so many papers at this stage. But anyway, that's kind of where I want to get to. So we're going to start here, and I was saying the beginning of this chapter is quite straightforward. It doesn't look at a glance, but it is. So the second derivative is literally what it says it is. It's the second you differentiate twice. So like, oh look, they have a nice little simple one here. So if y is x cubed minus 7x, then we know dy dx is 3x squared minus 7. And then basically if you differentiate again, right? So what you call it is d squared y dx squared. And you just differentiate again. So 2 by 3 is 6x, reduce the power by 1, and then the 7 is gone. And then you can do the same thing with the other notation. So this would be f of x, this would be f dash of x, and this would be f double dash of x. Yeah, and that's what a second derivative is. I mean, like, we can do it if you want. This is probably the most difficult one, so we'll give that a go. So it's a product. So u is 3x cubed minus 2x squared, and v is 5x plus 4. Sorry, I was trying to figure out if I could pause there. Anyway, du dx is 9, 3 3s are 9x squared minus 4x, and dv dx is 5. The product rule is dy dx equals u dv dx plus v du dx. So that is 3x cubed minus 2x squared times 5 plus 5x plus 4 times 9x squared minus 4x. Multiply it out. So 15x cubed minus 10x squared plus 5 9s are 45x cubed minus 20x squared plus 4 9s are 36x squared minus 16x. And then simplify. So what's that? 15, 50, 60x cubed. The x squareds are 36 minus 30, is that right? So that's 6x squared. And just minus 16x. So that is your dy dx. And then this question wants the second derivative. So we go d squared y dx squared, and we just differentiate again. So 360s is 180 x squared. 6x squared, sorry, is 12x. And then minus 16x just goes to minus 16. And that's your second derivative. Okay, so that's what second derivatives are. Differential equations is essentially where they give you an equation like this one, and the equation contains derivatives that you then have to sub in. So y is x e to the minus 2x. So this is a product. Yeah. So u is x and v is e to the minus 2x. So then du dx is 1 and dv dx. So you differentiate the e and you get it back, and then you multiply by the derivative of the power, which is just minus 2. So it's minus 2 minus 2e to the minus 2x. Okay, and then the same formula, so I'm not going to write sorry, this is not y, it's dy dx. So it starts with u, and then dv dx, and then plus v times du dx. So that is minus 2x e to the minus 2x plus e to the minus 2x. Like, I can take the e to the minus 2x out as a common factor, so it's minus 2x plus 1. And then to get my second derivative, I just treat this as a product again. I don't know if that's making it easier or harder. I've started, so I'll go with it. Okay, so out here, u is e to the minus 2x and v is minus 2x plus 1. Du dx is, I've done this already, so it's minus 2e to the minus 2x, and then dv dx is just minus 2, and then I can sub them back in, so u is e to the minus 2x, v is minus, sorry, dv dx is minus 2, plus v, which is minus 2x plus 1, by du dx, which is minus 2e to the minus 2x. Ugh. So this is minus 2e to the minus 2x, and this is, actually I might leave that, minus 2x plus 1 times minus 2e to the minus 2x, and then take out the minus 2e to the minus 2x. So here I'm left with a 1, and then here I'm left with just this bit. So it's minus 2x plus 1. So that is minus 2e to the minus 2x times 2 minus 2x, adding the ones. Ugh. Right, so obviously the calculus here, like with the e's, it just makes it really messy, but hopefully when I sub in, it will simplify nicely. So it says to start with the second derivative, which is minus 2e to the minus 2x times 2 minus 2x, 2 minus 2x. Okay, then plus 4 times, and then they want us to put in, so that's the plus 4, and then they want us to put in dy dx, which is here. So e to the minus 2x times minus 2x plus 1. Okay, and then plus 4y. Oh, sorry, and we need to sub in y, which is here. So x e to the minus 2x, x e to the minus 2x, and hopefully we're trying to show that that equals 0. So it should massively simplify. Well, right, so this one I should be able to just multiply like that, sort of. Always careful with indices, but the 2 by the minus 2 gives me minus 4e to the minus 2x, and then plus 4xe to the minus 2x. Okay, the next one, I'm just going to do this first. So that's just 4 e to the minus 2x times minus 2x plus 1, and I'll distribute that in a minute. And then the last one is 4x e to the minus 2x, and that should equal 0. Okay, so minus 4e to the minus 2x plus 4x e to the minus 2x. This multiplication gives me minus 8 the minus 2x and plus 4e to the minus 2x, and then at the end I have plus 4xe to the minus 2x, and it should equal 0. Please. Yes. Okay. So minus 4e to the minus 2x and plus 4e to the minus 2x will cancel. And then 4xe to the minus 2x plus 4xe to the minus 2x is 8xe to the minus 2x minus 8xe to the minus 2x. So it does equal 0. So there you go. Okay, so that's actually a really hard differential equation, but that's the idea. So they give you y, you find dy dx, you find d squared y dx squared. You sub it all in, and it'll tell you to make it's usually 0, to be fair. So usually it all cancels out. That was a little bit harder because the calculus was hard because of the exponential, really. Okay, so I'll give you a few of them to try. And this is the other thing I want to talk about. So increasing and decreasing functions. So essentially, okay, if you've got a function, so here's your x and here's your y. If you've got a function, say like this, yeah? So for this bit of it, the function is decreasing, as in it's literally going down. If you draw a tangent at any point along that green bit, so if you were to draw a tangent here, for example, that's terrible, but you know what I mean? So on a decreasing curve, a tangent to that curve would have a negative slope. Does that make sense? Like that black line has a negative slope. And remember, slope is just dy dx. So we're saying that dy dx would be negative or dy dx would be less than 0. Yeah? And then we'll talk about actually tomorrow. So on the other side, the curve is increasing. And on this side, yeah? On the decreasing part of a curve, if you were to draw a tangent, the slope of that tangent would be negative. So dy dx is less than 0. And if you're on a positive curve and you were to draw a tangent, the slope of that tangent would be positive, which is greater than 0. Yeah? Oh, sorry. So here's A is a closed interval from 1 to 5. So you can see on the graph, starts where x is 1 and it finishes there where x is 5. So that's what they mean. And then they define the function. So I don't know if you remember this from functions, but this is the name of the function. So the function is f. This is the variable that they're using in the function. So this function is as a function in terms of x. domain and the codomain, if you remember. So they're saying here that the x values are the A interval, which basically means the x values go from 1 to 5. And then the y values can be any real number, is what they're saying. And explain why f is strictly increasing on the interval 4 to 5. And the curved bracket of 4 means that 4 is not included. And the square bracket of 5 means that 5 is included. Right? So I'm just going to show you how to do this. So we're looking for increasing. Was that green, I think? Was it? Crap. No, pink. Sorry, try and keep my colours consistent. So we're looking for increasing, which means dy dx should be greater than 0 for increasing. Okay, so they're saying here that it should be increasing on between 4 and 5, but not including 4. So the first thing we have to do is get the derivative. This was defined as f of x, so the derivative is technically f dash x. It's a chain rule, so we bring down the 2, write the bracket unchanged, reduce it by 1, and multiply by the derivative of the bracket. So that just becomes 2 times x minus 4. Yeah? Now we want this to be greater than 0. Now look what happens if you sub in 4. So if you sub in 4, you get 2 times 4 minus 4. Sorry, I just went an extra line there. Which is 2 times 0, which is 0. Okay, so that doesn't work because remember I want dy dx to be greater than 0. Okay, but they did say that 4 shouldn't be included. Now what if it was just a bit bigger? What if it was 4.1? 2 times 4.1 minus 4 is 2 times 0.1, which is 0.2. And is 0.2 greater than 0? It is. Yeah. And it will work for all the numbers between that and 5. So let's sub in 5. So that would give us 2 times 1, which is 2. And is 2 greater than 0? Yes, it is. Okay, so explain why it is increasing across that interval. It is increasing because the derivative is greater than 0. Yeah? So here's another one. Investigate the values for which the function, so here we go again. The function is f. It's defined in terms of x, which we know. And then here are the x values, and here are the y values. Yeah, and basically what they're saying here is that it has to be always decreasing, and we know that for decreasing dy dx is less than 0. So we take our function, which is f of x equals x cubed minus 4x squared, and we do f dash x, which is 3x squared minus 8x. And we want 3x squared minus 8x to be less than 0 because we want it to be decreasing, and they want us to find the x values that satisfy this equation. So it is a quadratic inequality. So going back to our 5th year algebra, we let it equal 0. We solve the quadratic equation, which is to take it, it's a highest common factor, so take out x and then let each part equal 0. And then you have to, for quadratic inequalities, you have to sketch the graph. 8 over 3 is what, 2.6? 2.6 recurring. So 1, 2, 3. So it's like there somewhere. You draw your quadratic curve. And if you look here, we're looking for where it's less than 0, which is under here. So it is on the right of 0. So it's greater than 0. And it's on the left of 8 over 3. So it's less than 8 over 3. So if we sub those values in, so greater than 0, greater than 0. So greater than 0, I don't know, let's use 0.2. So if you sub 0.2 into the slope, so 3 times 0.2 squared minus 8 times 0.2. 3. You don't have to do this part, I'm just trying to see if it works. Crap. So I get minus 1.48, which is less than 0, which is what we wanted, because we want it to be decreasing. And then on the far side, so less than 2.6 recurring, so I don't know, less than 8 over 3, 2.5. So 3 times 2.5 squared minus 8 times 2.5 equals minus 1.25, which is less than 0. So it's working. Yeah. So investigate the values of x for which this function is decreasing. The values of x are values greater than 0 but less than 2.6 recurring. I wonder what happens if I actually put in 0. Oh, sure, if I put in 0, I'm going to get 0, which is not what I want. So yeah, it's greater than and less than as opposed to greater than or equal to. Okay, I think hopefully you've enough there. I might actually give you that one to have a look at for homework. So watch the video and then I will put stuff into the journal. All right.